Hey everybody, continuing the 3-7 video. What you're doing is you have one that's x equal cosine y. That's similar to what I did before that says x equals secant y. So we do our derivative of the left side, which is 1. Then the derivative of secant is secant tangent. Don't forget the y prime. So then we want to divide by the stuff in front of the y prime, and so that's 1 over secant y tan y. Now at first I split it and then I started doing all this stuff, which wasn't necessary because nothing was canceling. So even though it wasn't technically wrong, it's just not helpful. And so then I put skip to here. So if you have 1 over secant y, that's the same as cosine y. And 1 over tan y is the same as cotan y. So ours is going to be similar to that. So we're taking our derivative of x, which is 1, and your derivative of cosine y would be negative sine y, and then you have to put the y prime. Now keep the y prime where it is and divide. So you have negative 1 over sine y equal y prime. And 1 over sine is the same as cosecant. So this is negative cosecant y. So that matches. On 3-7 in particular, I tried not to do very difficult trig ones. At least that was my intention. Because I know that the other sections had harder trig questions. But this next one does have trig. So we have x plus cotan xy equals 0. So you do still have some trig questions, but I try not to make it that difficult. So on this one, an example is we have x plus tan xy. So the derivative of x is 1, the derivative of tan is secant squared. Keep the xy the same. Then you have to do the derivative of this inside part, and you have to use the product rule on that. So y times the derivative of x, which is just 1, plus x times the derivative of y. Once we have that, then we have to distribute. You have to do y times that, and again distribute. Then you had to group everything together. Like I moved the 1 over, and I moved this term over because it didn't have y prime in it. Then you basically divide by that stuff. And once you do that, then you put the negative 1 over everything. And then you have your y over x. Then we do change secant squared from the denominator to the numerator and make it cosine squared and go from there. Okay, we're about to do that. Okay, so on ours, the derivative of x is 1. The derivative of cotangent is negative cosecant squared. Keep the xy the same. Then you need to take your derivative of the inside parentheses part, and so that's the product rule section where you have to do y times the derivative of x, which is 1. Usually don't write that, but that's okay. Plus x times the derivative of y. So that's just y prime. And set that equal to 0. Now our next step was distribute, and so we keep the 1 how it is. And then remember, this was just y times 1, and so I'm going to say negative y cosecant squared xy. And then this one, we're distributing that times the xy prime. So I want the y prime first, because that's what we've been doing lately, and making it darker, just to make it easier. And then we have negative cosecant squared of xy. And that is equal to 0. So my first step would be move this stuff over. I'm just going to clean this up a little bit. Actually, I'm just going to leave it. And I'm going to bring the negative over, the negative 1, and then bring this term over, and so it's a positive y cosecant squared of xy. Okay, so now I need to divide by this stuff that's in brackets now. And so that's going to be negative 1 over, now I really am going to make that negative x here, and then cosecant squared xy. And then this one, we've got our plus y cosecant squared xy, and we're dividing by the same thing, negative x cosecant squared xy. Okay, now we need to clean it up and cancel. A negative divided by negative is a positive, and I'll just keep this as x in my denominator. Now, when you flip cosecant squared to the top, it turns into sine squared. So that did end up pretty clean after all. And then on this one, looks like our cosecant squareds are going to cancel, and so we have minus y over x. So if we just get a common denominator, see, I did that on purpose to make it easier for you to see this cancels. It's a little bit cleaner. And so now if we get a common denominator, and if we put the negative y first, then that'd be negative y plus sine squared xy all over x. And that matches what we wanted. So these are doable, it just takes a little bit. Okay, on the next one, this one's a little unique because you have 1 over y as your angle, so to speak. It's number 3713. Looks like what I did to begin with was use the product rule, and then I did my implicit differentiation, then factor out the y prime, change these to be in a better order, and then divided by that. And then I simplified this negative y times y to be negative y squared and kept that the same. So It looks like my note to the side was I multiplied by I multiplied by y over y. And so that's how come it became y squared. Okay, so we'll do the same approach. So we have 6y sine 1 over y equal 4 minus xy. We're going to use our product rule. Let's keep the 6y how it is this time, and then take the derivative of sine, it's cosine, keep the 1 over y how it is. Now we need the derivative of that part, which is negative 1 over y squared times y prime. For that, remember that we can say 1 over y is the same as y to the negative 1. And if you're taking your derivative, you bring your negative 1 in front, then you have your y, lower by a power, then you do need your y prime after that, which is what I put over here. So that's what we're doing. So that was keeping the 6y how it was. So that's the first step of the product rule. Then we need to say plus and keep the sign 1 over y how it is. And then multiply by the derivative of 6y, which would just be 6y prime. Then we take the derivative of 4, which is 0, and then we've got to use your product rule here. So the derivative of negative x is negative 1, and keep your y like it was. Then keep it negative x, and then the derivative of y is y prime. By now you might see why I like y prime better than dy dx. It's just less writing. And I do try to make it bolder. Okay, so that's what we have. Now it looks like we're gonna factor out our y prime. And so then we have a negative sign in front, and then 6. If it's y over y squared, that's going to be 6 over y. And then we have our cosine 1 over y. Then for this part, when we're factoring out the y prime, we just have a 6 sine 1 over y. And let's go ahead and bring the y prime term over. And when we do that, we're ending up with plus x. And then just keep this as negative y. So again, what we did was we kept our 6y the same. We took our derivative of sine, and that's cosine, kept this the same, then took the derivative of the inside, which is negative 1 over y squared y prime, Then we kept our sine 1 over y the same. And then the derivative of 6y is 6y prime. Then we took our derivative of 4, which is 0, and then used the product rule on this part. So the derivative of negative x is negative 1, keep the y the same, and keep the negative x the same and make y prime. And then from there, we were factoring out the y prime, and so we have negative 6 over y cosine plus 6 sine 1 over x. Then this part right here comes from when I move this over. I did a plus xy prime, and so I just put plus x there because that's like this. So that looks all right. So then we have y prime equal, keep the negative y on top, and this is where we have negative 6 over y cosine 1 over y plus 6 sine 1 over y plus x. Now, this is where you have a fraction over a fraction, which is not desirable. And so I'm going to multiply by y over y. So when I do that, you basically multiply every term by y. So this is where it turns into y prime equal negative y squared. When you multiply this, you end up with negative 6 cosine 1 over y, and multiply this by y, and so we get plus 6y sine 1 over y, and then multiply this one by y, and so we get plus xy. So then it looks like the last step is just divide your positives and negatives, like 2 negatives make a positive. So we have this to be y squared, and then just change this negative 6 to be positive 6. Keep it 1 over y, and then change the positive to a negative, 6y sine 1 over y, and then change this positive to a negative, so minus xy. And that's our answer. So that matches. Y squared is in the numerator, and then this 3 expression part is in the denominator. Okay, on our next one, it doesn't have trig anymore. So here we have 4x squared plus y squared equal 1. Now, it looks like a short problem, but notice you want the first derivative, which is y prime, and the second derivative, which is y double prime. So this one has 2 answers. So for the first part, we have 4x squared plus y squared equal 1. Take your derivative of this, which would be 8x, and then the derivative of this would be 2y y prime, and the derivative of 1 is 0. So then let's move the 8x over, so we have 2y y prime, make that bold, equal negative 8x. And then we want to divide by 2y, and so you get y prime equal negative 4x over 2. I'm sorry, over y, because 8 over 2 was 4. And so that's that answer. Now, on this next part, you can either use the product rule if you move it to the numerator with a negative exponent, or you could use the quotient rule. I think on this one, actually, I'm going to use the quotient rule because it's not a lot of terms. If we have y prime as negative 4x over y, then that makes this your u and this our v. And so what we want is v u prime minus u v prime over v squared. So the v is the y times the derivative of the numerator would just be negative 4 minus the u, which is negative 4x, times the derivative of the denominator, which would just be y prime, all over the denominator squared. And the part you got to watch out for is this is what y double prime is. Because we started with y prime. Now another part you're going to have to watch out for, I believe, is with this y prime, we've got to put this and do substitution. So let's watch for that. So y double prime is negative 4y plus 4x y prime over y squared. Okay, again, this y prime will be dark. Now we need to substitute that in. And so we keep it as negative 4y plus 4x. And then when we're plugging in negative 4x over y, that makes it a little bit different. We have a y here, like a fraction over a fraction. So we want to make everything multiplied by y. And so this turns into negative 4y squared. Or it looks like what they did is they put the negative there. But we'll do negative 4y squared minus 16x squared over y cubed. And that's the same as if you put the negative sign just out in front and then put 4y squared plus 16x squared. Oh, here I meant x squared over y cubed. So either of these. Now, I prefer like the negatives both in the numerator, but if you're trying to match the paper, they put one negative sign there and they had both of these terms positive. Be really careful when you're doing it because you got to remember if it's out to the side and if it's a compound numerator, then you're going to have to distribute that so it's a negative 16, which is what I have. So make sure you don't make a sign mistake there. Okay. Now we have one more. This one, we need the tangent line, which uses the slope, and we do the normal, which is the perpendicular. Okay. So for the example on this one, we have x squared plus xy minus y squared equal 1. Take your derivative, use the product rule there, make sure you do your y prime, factor out your y prime, and divide, and then you want your slope, and we're using the point 2, 3. So that means x is 2 and y is 3. So we're doing like y2 minus y1 over x2 minus x1. Actually, we're just substituting. We're put a 2 here and a 3 here and a 2 here and a 3 there. Okay, so we're actually just substituting in. And then simplifying. Then once we get our 7/4, we find our equation by using that y minus y1 formula, which is the point slope formula. And then we do our perpendicular line, so we have to change our slope by doing the opposite reciprocal and then plug that in. Okay, so those are our steps. So now let's do that on ours. We've got x squared plus xy minus y squared equal -1. And off to the side, our ordered pair is 1, 2. Okay, so for this part, we're doing our derivative. So we have 2x plus, here we have to do our product rule. So keep the y the same, multiply by 1, plus keep the x the same, multiply by the derivative of y, which is y prime, minus 2y, y prime, and then equals 0. Okay, so let's just simplify this a bit and factor out our y prime. Let's subtract these terms. So we get -2x minus y. And after you subtract those terms, then divide by x minus 2y. So that's our formula. Now we want to do the slope of the tangent line. And that's using 1, 2 for xy. So y prime equal -2 times 1 minus 2 over 1 minus 2 times 2. So that gives us -2 minus 2 is -4, and 1 minus 4 is -3, so that's 4/3. So now you want to use your point slope form. And remember, the concept is that the y prime is the slope. The slope is y prime. So then this would be y minus 2 equal 4/3 x minus 1. So y minus 2 is 4/3 x minus 4/3. And then we want to add 2 to both sides. So this is y equal 4/3 x. Okay, so I'm doing negative 4/3 plus 2, which is like negative 4/3 plus 6/3, which gives me 2/3. If you don't like getting your common denominator, just do that on the calculator. You get 2/3. So plus 2/3. And that is the answer. Now our next step is this is where we're getting our slope of the normal line. And so we take our original 4/3 and do the reciprocal. And so we get negative 3/4. So then we do our y prime, our y minus y1 is m times x minus x1. And again, we're using 1, 2. So x, y. Or you could think x1, y1. So this is y minus 2 equal negative 3/4 x minus 1. So then from there, y minus 2 equal negative 3/4 x plus 3/4, and then we have to add 2. So we have negative 3/4 x plus, if you have 3/4 plus 2, that's like saying 3/4 plus 8/4, and so that's how you get 11/4. And that is all she wrote. Okay, so hope that helps. Glad there were only 10 questions. Hope you have a good day.